Can you unmute me?
No, we're not hearing or seeing anything.
We know, trying to troubleshoot it.
Zoom doesn't work really good on a NASA computer at all.
Okay, I just unmuted. I figured out, I think I figured out what was going on. Okay, can you hear me online? Somebody give me a thumbs up. Okay.
And I can, and I
All
can see
right,
your
technical
picture.
difficulty. Can send people to the moon, and let's hope that we can do that again. Okay, microphone's not working, so if you want to move closer, it was working earlier. It was, yeah. So I'll just talk really, really loud. So if you want to move closer, you might want to do that. So, okay, we're gonna try this again. We're gonna get going here. Sorry about the delays. Unfortunately, the Wi-Fi that was going to be upgraded, that project has been pushed back. So stand by, bear with us. Hopefully we'll get through this today. So I'd like to welcome you to the NAL First Thursday program. I'm not touching anything, I swear. Okay, so today is June 6th, and I'm your program committee lead. I'm Lisa Spence. Just as a point of history, 80 years ago today, thousands of brave Allied soldiers stormed the beaches at Normandy. Their valor and sacrifices helped turn the tide on World War II, allowing us to enjoy many of the freedoms that we have today. So I hope you'll take a few minutes at some point in time today to reflect on that and express gratitude in your own way to all who have and continue to serve our country. I also want to let you know that we will not have a First Thursday program in July. That first Thursday in July is the 4th of July, so use your firecrackers wisely and safely. We will have a special event in July on the 19th as a tribute to the 55th anniversary of the Apollo moon landing. And I'll talk a little bit more about that after, if we ever get our speaker able to give his presentation. We'll talk about that later. So for our program today, our speaker is Mr. Frank Lynn. Frank's going to provide us with an overview of Artemis 1, as well as some information about future Artemis missions. So Mr. Lynn is the vehicle manager for the Artemis 1, 3, and 4 missions for the Orion program at JSC. In this role, he oversees, integrates, and coordinates the development and production of the Orion spacecraft from end to end. He also provides program leadership for spacecraft processing and Artemis mission execution. Prior to becoming the Orion vehicle manager for Artemis 3 and 4, Mr. Lynn served as the vehicle manager for Artemis 2 mission alongside Artemis 1. He was also the European Service Module Integration Lead in the Crew Service Module Office, overseeing the development of ESM structural, mechanical, and thermal control systems and their integration into CSM systems. There's not much that he hasn't done, just saying. He also spent time as the production and assembly lead, coordinating with the Orion Production Office, assuring hardware and engineering were available to support critical assembly milestones. Since joining NASA in 2011, Frank has held several technical and project management positions. He has worked on conceptual design for future interplanetary spacecraft, space shuttle orbiter thermal protection systems, and on-orbit repair of orbiter thermal protection systems. Prior to joining NASA, he worked at KSC as a structures systems engineer, processing orbiters and solid rocket boosters. Frank has a bachelor's in aerospace engineering from the University of Florida and a master's in space systems from Florida Institute of Technology. I'm going to tell on you. He is also the proud father of a recent college graduate, and he just returned like 2 days ago from a month-long graduation trip to Asia. So please be kind to him as he's still adjusting to Texas time. So I'm going to turn it over to Frank.
Thank you. It's definitely a pleasure to be invited to come here and talk to you all. And it was really shocked when I walked in. I see some familiar faces. Billy Mack is right there. Billy was my old boss when I was in Warburg Project office. Keith, I worked with. And online, I saw lots of names on there, right? I saw Fred, right? Fred is on. I saw Gwen Hale, Susan Boss. So those are all the people that I used to work with, either back in the shuttle days, ISS, my short stint in ISS there, about 2 years or so. So anyway, so glad to be here. And so what I'm gonna do today is I want to kind of show you some of the videos, highlights of the Artemis one. Some of you may have seen it, some of you have not. Hopefully this will give you some idea of what we actually did during the Artemis 1 mission. We'll talk about that, and we'll talk about Artemis 2, 3, and 4, what we are doing there, what we're trying to accomplish there, and also I'll show you some baby pictures of the different vehicle that's currently at KSC right now, at ONC. Okay. All right, so I'm going to show you a video. I hope you guys can hear it or see it. Let me see. You got it? Or not, you hear?
And liftoff of Artemis 1. It's a new era of pioneers, star sailors, and adventurers.
We're going beyond anywhere we ever went for Apollo.
Oh, that's
Splashdown. Orion, back on Earth.
That's a pretty good video, unfortunately.
Well, people in the room
All right, so
I think
we can just skip it and we'll go to the next one.
we could have just let it play out and go online.
All right, so
Well, here, tell you what, let it play for a second. We'll see if I can play it on the speaker. This one's
okay, great. Let's do that.
go ahead and play it.
So do I need to go back?
No, I got it.
You got it? Okay.
Don't touch anything, Frank.
Don't break your pen.
Let's try the map.
And liftoff of Artemis 1. It's a new era of pioneers, star sailors, and adventurers.
We're going beyond anywhere we ever went for Apollo. Splashdown. Orion, back on Earth.
And there's a lot more coming.
Our destiny is always to go and see what's further and what's next.
They're actually metal is being bent, shaped, formed to build the things that we're going to use.
We are going. This is reality.
NASA is at a historic inflection point, poised to begin the most significant series of science and human exploration missions in over a generation.
Astronauts will live and work in deep space, and will develop the science and technology to send the first humans to Mars.
I'm really looking forward to all the science we will conduct on the moon, the samples we'll bring back, the knowledge we'll gain from understanding the lunar environment better than we ever have before.
The more nations and companies at the moon, the more we learn, increasing our capabilities while strengthening things right here on Earth.
We are going to the moon to learn how to live on other planets for the benefit of all. Let's go.
Okay, so that's a video of, like I said, we always show that video because it's pretty inspiring. because it's got powerful. Unfortunately, we don't have the sound system here to really give you the sense of the launch, right? So Artemis, what's Artemis, right? You know, the Artemis 1, the Artemis 2, I always say that the only three programs that are really involved. Orion, the spacecraft, okay, with the launch abort system on it. We had EGS. EGS is the exploration ground system. Essentially, what I find auxiliary we call it ground operations, you know, of the guys at KSC. Then we have the SLIs. SLIs essentially space launch systems, and that's essentially the ETs and SRB, which I'll be thinking that way. And that's SSMEs, budget shuttle. So that's 1, 2, and 3 is going to place most. And that is how we HLS. So what you saw today launched by SpaceX, the Starship, is essentially, you know, with the spaceship. That's exactly what we're going to land on the moon one day. Okay, so that's what SpaceX is building right now. That's part of the human landing system that's managed by Marshall Space Flight Center. And then we have the space operations. We have the surface mobility. They all at spacesuit. They all being managed here at JSC. And the Gateway program is also managed here at JSC as well. Gateway, I call it a miniature space station. They don't like it, but that's, to me, that's exactly what they are. Okay, so Gateway, Artemis 1. That's when we start putting up the modules out there. We can dock to it. But for 3, we'll do a direct docking with the Starship, and then we'll go to the moon and come right back. Okay, so I'll talk a little bit more about that later on. All right, let's go to the next page. So Orion. Orion consists of, like I mentioned, the crew module, obviously. Okay, that's a shiny piece where you see the Cyox tape on there. We have the service module right there. Service module, essentially, we call it a service module adapter, CMA. It's a ring that kind of goes between the crew module and the European service module. The service module, main part of it, the bottom part of it, that part houses the propulsion system, the power generator system, and also the commodity storage system, oxygen, hydrogen, and also oxygen, nitrogen, as well as water. Okay, it also generates power, and it's actually provided by our counterpart, European Space Agency. Okay, Airbus is one that actually integrates the vehicle together and delivers it to NASA. LAST is very similar to the Apollo escape rocket, right? The tower at the top. Provides a launch kind of a escape during a pad or during ascent. Okay, for the first 3 minutes or so. All right, so let's go to the next page. What do we have? So Orion, here's kind of a specs for Orion. I won't go to a lot of details. 78,000 pounds at liftoff, 20,000 pounds, 27,500 pounds at landing mass. It's really designed for 4 people for 21 days. Okay. One thing that comment was that the accommodation, I always find it interesting. The Hapla volume is 78.5 cubic feet per crew versus the Apollo command module, it's 70. Okay, so they get a little bit more luxury, up to 40, 50 years. Okay, let's go to next page here. So let's get into the Artemis 1. So next page. Artemis 1 launch was after several delays, including a couple of hurricanes. They actually came through Florida. That we had, in the last hurricane that was there, we actually ended up staying on the pad and sustain the weather, the hurricane. We launched on November 16th, 2022. It was a beautiful launch. Some of you guys have probably been in LCCs in the KSC. I happened to be on console that night, and when it come down to T minus 30 seconds or something like that, right? The entire room goes very, very quiet, and you can just hear a pin drop. It's the clock, they are announcing the clock countdown, and then about T minus 10 seconds or so, I know that it wasn't much for us to do. We can't do anything anymore. It's automatic countdown. So a bunch of us went out to the VIP section and tried to look outside to watch your launch. So that was a mistake because if you know the LCC with the windows outside, nice and big windows, and it was all just dew all over the place. So there's nothing that we can see. Everybody else out of Blina River or anywhere else, they saw a great, beautiful launch. All we saw was a global fireball launching into the sky. Anyway, so let's go to the next page. So here is the orbit, the Artemis 1 that follows. We launched from the Earth. We went ahead and did the outbound. We met out the moon outbound flyby, and we went ahead and did a get into the lunar orbit essentially. Spent about 6 days right there, and then we got out of it, and then we come back. So a total of 25.5 days. And I got some pictures to show you for the whole mission. Let's go to next page. So here's the last jettison. So this is something that we put cameras inside the crew module, so that we can see, how the last jettison, how last gets jettisoned. So you can see the last jettison, or the plume last being awake, and the attitude control motor steers it away from the vehicle as well, still ascending to the sky. Okay, next one. So next one, after we successfully got into orbit, okay, then the first thing we need to do is, the next shuttle had the fuel cells, and Apollo, we actually have solar wings. So we have solar wings, and then the first thing we need to do is deploy our wings to make sure that we have power before we go to the moon. Okay, so right here, what you see here is actually, and what we did was we put cameras on the tip of our solar arrays, those 4 solar arrays, and those 4 solar arrays is what give us all these great images that you have seen today.
It's your video start.
Whoa, what did I do? Did it do anything?
No, there's still no camera. I wouldn't worry about it.
All right. One of the things that we said about, it's unfortunate I couldn't show you earlier, was the video on the solar array wings. Is we have always joked about to say that to us, those solar array wings ended up being the world's biggest, longest, as well as the most expensive self-sticks, because that's what we use to take pictures of ourselves, the vehicle. We inspect our vehicles, as well as taking all the images you're going to be seeing in this presentation. RCS engines fire, you can see that, we're also trying to figure out and also determine how effective is our RCS jets on the vehicles, right? So we can determine what kind of propellants efficiency burning is, and then we can go ahead and try to budget it appropriately and give us additional margins. So we did all that. You can see the jets firing, so it's pretty good. Let's go to the next one. So day 1, so the first day that we went out, we went to the T, we exported and deployed the wings, the solar array wings, and this is a picture we have taken. So this is a picture that was taken essentially, since 1972, the last Apollo mission that went to the beyond low Earth orbit. Here's a human space-ready vehicle, and the first a picture of the Earth, behind it. So it's pretty iconic, pretty great picture of that. And Friday 6 is the day that we're gonna. Friday 6 is the day that we actually get into the lunar orbit. That's when the OPF starts, the outbound power flight starts, and we get into the lunar orbit. You can see as we approach, the moon is coming between Earth and the spacecraft. Okay, Friday 13. This is the day that we actually gone beyond the world record that Apollo 13 sets. Okay, we went to 268,000 miles beyond, from Earth, and which is 20,000 miles beyond Apollo 8 big adventure. So we set another world record there. Next page. Friday 20. So Friday 20 is when we start coming home. It's time to come back after we do about a rev and a half in the DRO, the distant retrograde orbit around the moon. And we just come home then. And the Friday 20 is when we are doing our return flight power, return power flight. And at this point in time, we actually, at some point during time, we actually get as close as 80 miles within, to the lunar surface. Pretty impressive. You can see all the craters and all the images we took, all with those 4 really GoPro cameras that we put on top of the wing. GoPro 5. Keith worked on that. All right, so re-entry. So after 25.5 days, 1.4 million miles, now it's time to come home. 400,000 feet, entry interface. We hit it, right? And you can see, in addition to our commander, we also, which is our Campos, we also have our Snoopy with us. The Snoopy flew with us. It becomes our geology indicator. That's something that we always fly on the spacecraft, I was told. So we can see the light outside the windows. The astronaut would be seeing. It's pretty impressive. This video, did you guys hear it? Obviously, it's taken from inside the cabin, and all the plasma is coming out of the vehicle from the heat shield and reconverge into the fireball that you see there from the floor. And one of the things that I always found interesting, and when I saw this video the first time, was the clunking sound that you heard online, right? The clunking sound is actually all the valves opening on the jet. I never really thought that that's what the vehicle would sound like, right? I guess I've been watching too much science fiction movies where you don't hear that, jets firing, but I'm like, psst, psst. That's not how it is, So it's more of a clunking sound because the valves are open. Okay. Is it?
So this one also sounds right. You want to say something
We
before?
can't hear you on the net when you're talking.
Okay, so the next one is the parachute deployment. So 400,000 feet, we hit it in the atmosphere and for entry interface. What we did is, for the first time ever, we actually did a skip entry with a human space-rated spacecraft. Okay, skip entry being, instead of coming in a guided entry, direct entry, what we do is we come in from 400,000 feet, we went down to about 200,000 feet, we actually tilt the vehicle up and bounce up to about 300,000 feet and come down. The reason why we did that was to give us the extended downrange. We're trying to prove that one of the objectives for this Artemis 1 flight is to demonstrate the heat shield capability and also demonstrate the skip entry capability, because that gives us the flexibility and also the on the launch windows, as well as when we can land, and just give us more flexibility and when we can launch as well, and where we actually land, because we actually have a recovery ship to go get the vehicle. Let's go ahead and play this video. So what you saw here is the parachutes, obviously, but at the beginning of the video, you will see the vehicle, the Orion actually have a total of 11 parachutes. Okay, we have 3 parachutes to take this 4-bay cover away from the vehicle. That's what protects all the crew module upright bags, as well as all the parachute underneath it. Once that is out, we deploy 2 drogue chutes, okay, to slow it down, to stabilize it. And eventually we pull out the 3 pilot chutes for the 3 main chutes, and then the 3 main chutes then deploy. Once we land, so we stop at 25,000 miles an hour, right? When we do the first atmosphere re-entry, when we touch the atmosphere, 25,000 miles an hour. And then about 19 minutes later, we splash down off the coast of San Diego at about 20 miles an hour. So within 19 minutes, we were able to decelerate the vehicle down to about 20 miles an hour. All right, so some of the highlights for Artemis 1. This is something that our power guys keep on telling us that don't count on it, right? Because they say, hey, we actually generated 22% more power. And then they would say, that's a great thing, right? Everybody wants more capability, right? But the power guy's saying, well, no, because the time that we fly, you get more solar energy, the way we flew it, the altitude that we flew. So really, you cannot really say it's 22% more, but we're going to take credit for that. Okay. 25% less power consumption than predicted, which is also a great thing. But our thermal guys are saying, well, you know, that's not really true because again, the way we flew our altitude, it requires less thermal energy, so there's less power for the heaters. So therefore, it behave better. I think they're just doing that just make sure that they don't get sandbagged. They're just trying to sandbag them, I think. We actually downloaded 155 gigabyte of data. A lot of them were telemetry, but a lot of them were videos, pictures, etc. Okay. And the vehicle did really, really well. How often can you actually come to the mission and you say, you know, the vehicle is doing so well. So we had 140 FTO and DFTO plan to go done. And the vehicle is doing so well. Our controllers were sitting around saying, you know what? Why don't we do more? So we added 20 real-time DFTOs. Now, it sounds great, right? But it sounds a great idea. Everybody wants a first vehicle, do more. And then later on, they find out that by adding in more DFTL, it really involves a lot of people, a lot of time, a lot of work to make sure the vehicle's gonna be safe and we can do it all. Okay, so that's lessons learned. We actually say, don't ever do this again. We're actually gonna plan it. We're gonna go in our books. You know, if all goes well, these are the things that we can go do. And then the FOD or MOD back in the days, they're going to determine how are we going to execute it versus discussing real time, should we do this DFT or not? So that's something that we learned not to do again. I mentioned 1.4 million miles total travel over 25 and a half days. You know, we traveled the first ever for a human-rated spacecraft, 268,000 miles from Earth. And then again, the first, you know, skip entry for any kind of human human-rated spacecraft. We actually splashed down at 2.4 miles from target at 16 miles an hour, as I mentioned before. I think it's like 20. But our GNNC guys, they actually challenge us to say, you know, it's not 2.4, it's actually 0.6. And the reason is because, you know, they say we determine the target, you know, the final when the chute deploys, right? It's actually 0.6 miles, you know, from the actual target. Now, once the chute deploys and come down, it's up to the atmosphere, whatever the wind carries them. So the actual splashdown is 2.4 miles away from the target. He said we have no control over that. So to them, if there's no wind, they would have been pretty much dead on, 0.6 miles from the actual predicted target space. So that's pretty good. So let me go to the next one. So we completed Artemis 1 back in 2022, and what are we doing now? Artemis 2, as you know, we picked the 4 crew members, okay? And they are going to be going right now. The launch date for Artemis 2 is September 2025. It's going to be next year, September. Okay, and they involve the SLS, as I mentioned, Orion and EGS. Artemis 3, right? That's going to be a year after, September 2026. That's when we actually land the next human, human on the moon again. Okay, so that's going to be 3. Artemis 4 is when we actually dock with Gateway. We're actually going to put the co-manifest payload with the Gateway I have with us, and we're going to push it out to Gateway and dock with there and form a kind of a miniature space station there. And then Artemis 5 is when we started putting, hardware onto the surface. So that's kind of the succession of what we are doing now for the next few years. Let's go to the next page. So here's our crew member for Artemis 2. So we have, let me see we have Jeremy Hansen. He's actually our Canadian astronaut. He's a rookie, never flown, I think. And then we got Victor Glover, we got Reed, and we got Christina. They're all veteran astronauts. So these are our 4 crew members for Artemis 2, and they'll be ready to go for the Artemis 2 mission coming up next year. So let's go to the next page. So what are we doing in Artemis 2? So the purpose of Artemis 1 is really to show that we have a spacecraft that is capable of taking human to space, and then to demonstrate that all the systems on the spacecraft is going to work as we predicted, understand how the spacecraft performs so we can validate our design, essentially. So that's what we did. We successfully had done that. Artemis 2 is we're going to put crew member on there, okay? But we don't want to make sure that we don't stretch too much. So we say, okay, well, we're going to put them in there. We're going to fly it to the moon and come right back. It's going to be a free return trajectory. Essentially, once we do a TLI burn, the translunar injection burn, it's going to go around the moon and come right back. There's nothing else they need to do. Just go in there for a ride and come right back. It's about 10.5 days, and that's all we're going to do. Okay, but what's the purpose of Artemis 2? Let's go to the next page. And there's more, right? So the 10-day mission, we're going to go ahead and for the first 24 hours, once you get into orbit, we're going to do a rendezvous and park stop. We're going to go ahead and separate from ICPS, the inner cryogenic upper stage. That's what essentially upper stage. We're going to go ahead and turn around and try to dock with it. Not docking with it, doing park stop, get close to it, and back off. And they should demonstrate that we can actually control the vehicle for future docking, because we got to do that for Artemis 3 with the Starship. Okay. Let's see here. We had the first time we are flying crew in the spacecraft. So we're going to make sure that we have the crew displays and the controls are good. Environmental control system, because on Artemis 1, we didn't really have we didn't fly environmental control system, ecosystem. So we are doing that for Artemis 2. The suits, they're also brand new suits. It's not an old shuttle suit. It's actually a brand new ARC suits. Of course, you got to make sure that the potty works, right? So you got your universal waste management system that has to be work. Okay, so let's go to the next page. So here's some pictures of the Artemis 2 crew training for their missions. Next. And then here are a couple of pictures of the vehicle. The picture that you see on the left-hand side, this is the Artemis 2 spacecraft, the crew module and the service module that's actually being lifted up and put into the I would call it the vacuum chamber at the ONC. And believe it or not, that's the same chamber the Apollo 11 capsule was actually put in and do a testing as well. So it's pretty iconic there. The left-hand picture on there, that's where you see the whole vehicle stack without the launch aboard system on it. Okay, that's the next page. Artemis 3 orbit. So Artemis 3, as I mentioned, we're going to go to the moon. We're going to go to this NRHO orbit, and we're going to dock with the Starship, and then Starship will then take 2 crew members to the surface for about 6 days, come back, and then we'll come back. So it takes about 12.5 days to get out there. 3.5 days in the dock operations before the 2 crew members will go to the surface for 6.5 days, come back, stay there for about 3.5 days, and then the return trip is about 5.5 days. So a total of up to about 34 days. So that's about the mission duration. Okay, next page. So Artemis 2 obviously is getting completed at KSC. It's really almost done. Okay, so Artemis 3 is also being worked out. Here's a picture of Artemis 3 in our approved cell, where we're undergoing some sort of essentially the proof test of the pressurization test. On the left-hand side of the page, to my left, that's the European service module. That's at Bremen, Germany right now, and that's being put together. We are expecting the ESM3, European Service Module 3, to come over to sometime in September, August or September of this year. So while we're doing 2 and 3, that's not enough. So let's go ahead and do 4 and 5 as well. So here's Artemis 4. Artemis 4 crew module is at KSC right now, and it's being outfitted, and it's actually being putting on all the secondary structures outside the pressure vessel. It's also being worked out. A lot of components are being put together as well, systems to be put into the vehicle. And then the Europeans are also, Airbus is also busy putting together the European service module for Artemis 4, ESM4. Next page. And that'll be all done. Artemis 5 is also in works. It's not at KSC yet. Here, this one right here, this picture right here is the European surface module. You can see the composite shear panels. Here's the aft bulkhead. And on the right-hand side, you can see the Artemis 4 crew module and MAF. That's the com panel, we call it. You can see the three of the four windows on the right, and the European service module on the bottom of that. I'm sorry, that's 6. Wow, that's pretty good. I didn't even know 6 is already in there. Just showed up. Okay, just showed up from Tazi, Italy. So that's all I have. Kind of concludes on Artemis 1 accomplishments, what we have seen, what we have done. Give you a kind of glimpse of, not just 2 that we are working on, right? We're also doing 3, 4, and 5. And as Erica mentioned, we're also doing European ESM 6 as well. So are there any? I'll just go ahead and take questions now if you guys have any. Wow, that's a lot of quick. So I'll go with you first since you are closer to me.
Frank, can you tell us what is the plan to reuse some of the hardware between command modules?
Okay, so the vehicle has been designed for reuse, but we are doing a lot of work right now trying to determine what else we need to do, what other tests we need to do to be able to reuse it. So right now for Artemis 1, we actually took about 12 or 13 components, avionics boxes. We refurbished those, and we're actually flying on 2. Okay, the plan was that when 2 comes back, we'll take more hardware from it. We'll harness it, we'll repair it, and we'll do it maybe on 5, I believe. And then eventually the goal is to complete reuse, not complete, I wouldn't say complete reuse, but I would say 80% reuse of the entire crew module. So that would be our goal in the future.
Including the pressure vessel?
Yes.
Except for Artemis 1, which is used for structural tests.
Yeah. Yes, the Artemis 1 right now, it's actually the vehicle that came back, we actually put it back together. We actually ship it to Glenn Research Center. It's actually in the Armstrong Test Facility at Plumbrook facility. It's actually undergoing environmental testing right now. Yeah.
So shortly after the test mission of Artemis 1, I heard stories that the heat shield didn't perform well, but it was another year before I actually saw any photographs in the public domain. Why did it take so long to release those photographs?
I don't think I'll be able to answer that question as to how come it took so long. I can tell you that heat shield performed. How can I keep that? I think it performed well. It did not perform it. What we didn't understand is why did the char liberate? We didn't understand that. We had done all the
big chunks missing to me. I mean, it looked horrific to me. I mean, it looked well beyond what you would expect.
It's a half inch of char, and there's still sufficient virgin material on the bottom of it. It looks bad. Okay, but and I'm not going to argue. It looks bad.
It looked really bad.
Okay, so the question was for Artemis 1. After Artemis 1 came back, the heat shield had. So I would say that we saw some unexpected conditions of the heat shield. Okay, char liberation excessive of what we had expected to see. Okay, it took over a year until NASA officially released the photos, and my response is, I really cannot tell you why it took that long. That's really, I would say that's above my pay grade. Okay.
Well, historically, heat shield technology gives a lot of, ITAR export control issues. I wonder if that had something to do with it.
Can I ask, where did you see the photos?
About 3 weeks ago, they came out in the, space.com.
Yeah,
and all the
there was it.
Yeah.
So I would say that we were trying to figure it out and investigate what exactly happened. So we didn't want the photo to be released at the time. Why did it take a year? I don't know. But initially it was about, we saw it, we tried to understand it, and we want to make sure we understood it before we release the photos. Because there's no point in releasing the photos and then tell you that, well, we have no answer to it either. right? So we did a lot of investigation. I'll tell you today that we actually know what causes it. Okay, we know exactly what causes it. We already planned on what we're going to do to address it so it won't happen again. So I can tell you that.
What's that?
What is what?
What's the workaround, the go forward plan?
The forward plan is actually to reduce the density of the AFCO material. What happened was, we believe what's happening is that the pressure is being trapped inside the billets when we come down and try to do a skip entry. As we coming down, right, and in the atmosphere to 200,000 feet, it's burning, right? We are charring the material, gases, the pyrolysis gas is escaping. When we start coming out to the skip, it started to cool, right? When it started to cool, it started to densify. It started trapping gas in here. So when you started coming down again, you're still heating on the material again. So you pop that thing off. I think STS-1, 2 shuttle, I believe that we have similar type of observations for the coating, the glass coatings on the tile as well. So there's something that we did not expect, and we know it now, and we are trying to find a way to address it. Bill?
So Frank, on Starship, when it's sitting on the lunar surface, where's the egress ingress hatch?
It's pretty high up. So they actually have an elevator that lowers the crew down and brings them back up.
And the backup plan?
I don't know.
So, I don't know.
Repelling.
I heard someone mention that there is a manual way to activate the elevator.
Yeah, perhaps. So Bill's question was for the Starship, once we land on the lunar surface, and how does the crew, where is the ingress and the egress hatch located on the vehicle? And my response was that it's pretty high up on the vehicle. Then the follow-up question was, well, how do they get in and out? And obviously, and also what's a contingency? My understanding is there's actually an elevator that lowers and raises the crew member to and from the lunar surface. Regarding the backup contingency mode, I don't really know. And perhaps it's a manual way of getting it up. I don't know.
I think someone mentioned there's like a manual backup mechanism, but it's like 50 feet above the lunar surface.
Yes, it is. It's pretty high up.
On the NASA Today thing that they sent out every morning, yesterday they showed some testing of this, and the airlock they said the airlock is right below the crew module, right? And then it had the exterior door there, and somehow the elevator. I wonder how is it collapsible? How do they get the elevator?
So it's an elevator. I think it's like a hoist or.
It looks more like a window washer, kind of ladder kind of thing with cables on each side being lowered down.
Yeah, since I work around, I don't have all the details on that. So, but I do know that it's an elevator type of concept. The detailed design, I'm not familiar with. It's an adventure. Go ahead. Let me get you.
Is that gateway that orbits the moon, is that absolutely essential to continuing these lunar missions? Because, it's expensive enough to operate logistically something in low Earth orbit. Now you got something in lunar orbit. If you have a failure there or something like that, what's the contingency to repairing it so you continue with the Artemis missions or replace it? Otherwise you're dead in the water, aren't you?
Well, very similar to Artemis 3, that we did a direct docking with the Starship. So I think from a contingency standpoint for Artemis 4 and beyond, if there's an issue with Gateway, then I think the workaround would be for Orion to dock with the Starship directly. The astronaut can still do some missions. I'm not sure if they can do the whole mission because Gateway really is where they actually dock with it. They take their couple of days of reconditioning before they go down to the surface. Gateway also provides some platform for telescoping, for anything like that as well. So it has some benefits to it, but from a lunar surface exploration, I think it provides more of a depot, a rest stop. I call it. I don't know. That's my understanding of it. Okay.
Doesn't it provide you something that's landing capability? more locations that you would normally have to just do the docking you're talking about?
I think it does that as well. The orbit that's going in, right, I give you some opportunity to be able to go down to different areas on the lunar surface. Yeah. Yeah. But if you cannot dock with it, right? If you have the issue with it, then all you have is a starship.
I know this is beyond your vehicle, but you mentioned Artemis 5 has a crewed mobile surface exploration. Is that a lunar rover? What is
Yeah, that's exactly what it is.
This will be done pressurized.
I don't know if it's pressurized. I know that pressurized rover is in work, but I'm not quite sure if the first one will be pressurized or not. Yeah, I'm not as familiar with that.
More near term, what are some of the technical issues that are driving the Artemis 2 launch date, which seems to keep slipping to the right?
Well, you probably already heard the heat shield. He mentioned it, right? So we got everything pretty much elected now. I'm pretty sure that I think the heat shield problem is behind us. I think it's a big deal. We want to make sure that's what protects the crew from coming back, right? So we want to make sure that the vehicle is safe and the crew is safe. So I think that's behind us. Recently, I would say that we have a battery issue. We found out that the battery did not survive the qual, okay, for the abort case, not for nominal mission. For the abort case, abort vibe, it puts more of a severe vibration environment that actually reduces the capacity of the battery. Okay, so that is our latest challenge right now, and I think we understand what the root cause is now as well. And we about to take out. We actually took out the batteries already, and we are repairing it based on that. So that to us, that's the two major challenges we have right now for two, at least for Orion. I know that KSC, EGS, they may have some, they suffer a lot of damages from Artemis 1 launch, from the blast. And so they had to go ahead and fix the ML, mobile launchers, the elevator doors and things like that. They also encounter some, I guess a lot of welding issues they have on tubings that supplies the commodities to the vehicle. So they are overcoming that challenge right now as well. So that's what I know. SCLS has been doing pretty good.
Are these support batteries being just changed, or are they being redesigned?
The Artemis 3 batteries is different design than Artemis 2. Artemis 2 battery, it's a large cell battery, right? It's not small. It's not a small cell battery like Artemis 1. But 3 is different. So 2 is a unique design.
Yeah, they go to the small cells.
Yeah. Yeah.
So you're using the same batteries that were planned for 3 now being put in 2?
No, 3 is a brand new design. Artemis 2 design is different. It's unique of itself. But we are repairing it because we know what the problem is, and then we are fixing it right now. It's really just more of a material issue that the adhesive that we use wasn't strong enough to keep this inner cell connect plate from debonding it. And when you start debonding under the vibration environments, you got these fusible links, real small tiny links to the battery contact. It breaks. It broke, and that's the reason why we are redesigning to make sure that the interconnect plate is not going to come debonded by adding additional fasteners just to keep it down there, keep it bonded. Go ahead.
So Artemis 3 is going to land in the lunar south pole. Is that the same for 4, 5, 6? What about the other missions?
So I know, 3 is going to be on the south pole. The question was, Artemis 3 is going to land on the south pole, but what about the outgoing missions beyond? I actually don't know. I'm not quite sure if the agency, the Moon to Mars program director have any. They are discussing that, yes. I think they are still planning those missions. But I know for 3, it's going to be on the south pole.
So I don't know if you had a chance to watch Starship test number 4 today.
I saw.
They had a wealth of communication, a wealth of camera views during dynamic flight, and they had 1.2 million people watching the SpaceX stream There's probably a dozen other streams on the internet carrying it. What kind of coverage are you going to be able to offer the public from Artemis during the missions?
Okay, so the question is though, for the Starship mission, the flight that you saw this morning, there were a lot of cameras, there were a lot of video images, and then it was shared with about 1.4 million people, right?
On SpaceX
on
alone.
space alone, right? So for Artemis, for Orion or Artemis, I know that it's what you described was actually a lessons learned that we got from Artemis 1. And what happened was we were not prepared. I would say that we did not expect, and we didn't know the first time we flew it, right, the vehicle. So we are trying to figure out how to work it with the ISS. So we actually, and that's a lessons learned, and we're actually fixing it for Artemis too. So we will have more capability, real-time images, real-time videos, and then we'll be able to share with the public. All the details, I don't have all the details, but I know that that's something that we want to strive for to get it to improve.
Yeah, I mean, they're the people that are paying the bills. So
yeah,
if you don't engage them into the process, you're going to hurt your long-term process.
Agree. And so that's something that we acknowledge, and we are fixing. That's like I said, it's a lessons learned from all of us.
There's a question online.
Go ahead.
Question online. Go ahead.
Are you waiting for my question? This is Bill Wepner. I had two questions.
Yeah,
Do you have
yeah,
any?
Bill, go ahead. Hang on.
Do you have any interior photographs of Orion? Number one. Second question. Will the landing system be SpaceX or Bezos?
It's a question of
Orion interior. What happened to my sound?
Repeat the question.
Are there any photos available of the interior of the Orion spacecraft?
It is. Okay, so yeah. Yeah, the videos of pictures of the Orion interior is available on Orion Flickr. And Erica would post that link on the chat so you guys can get access to it. Any other questions?
I have one.
Oh, Keith. Of all
Frank,
people.
And Brayman, what was your favorite beer?
No comment. Francis Connor, that's what I like the best. Right. That's what I like. My boss, well, you know, some people like the polymers, I guess, but anyway, I got used to drinking wheat beer. Never had it before.
There's one more online. Yes. No, that's the same.
All right, any other questions before we wrap it up?
Go ahead. Yes, they are. Yes. Yeah, so the question is, will SpaceX or HLS program have a demonstration flight, unmanned demonstration flight before they actually put the human on board? Yeah, the answer is yes. You know, their plan is to do an uncrew docking. Matter of fact, that's how the contract was structured. They were going to go ahead and dock, and I'm sorry, they'll go up there and actually land on the moon. And I believe they're supposed to just kind of lift off to make sure that the vehicle can actually lift back off to the lunar surface. And then that is the objective of that uncrew mission. And then the following, then before Orion will actually launch dock with it, they need to demonstrate that. So that is a plan.
plan in case Starship can't pull that off, because it seems like they had some problems with re-entry. I'm sure they'll iron it out. Today they seem to melt it within the first time they lost a bunch of tile and burned it up. So a lot of work to be done.
I don't know about any contingency. Yeah, I don't know about a contingency. I know that it's the question is there any contingency plan in case the SpaceX is delayed? I think the agency or the Moon to Mars director is looking into are there alternative maybe alternate missions that we can fly. In case that SpaceX delayed and the SLS is ready to fly, Orion's ready to fly, the vehicle is ready to go. But if HLS is delayed, and I think the agency will be considering maybe an alternate mission so that we don't have the vehicle sit on the ground, just sitting there. We have a lot of, as you know, limited shelf life items, right? So we need to go ahead and launch. Otherwise, we might end up having to go ahead and remove those items, and which would becomes really expensive, right, and time consuming.
Starship can be used to go back and forth between Earth orbit. I mean, what is it? One use thing, you gotta launch a separate lander every time. So
I don't know about that. I
Starship
think that
will
that
refuel in low Earth orbit, then it'll go to the moon, and it'll be a special Starship without the wings that it melted off today or had damage. So it'll be a different structure, a different vehicle. It obviously will have this elevator and crew capacity. So I don't think we've seen what that final design looks like.
Yeah. So I don't know how to answer that question. What is Starship going to be reusable? I think that's your ultimate question, and I don't really know since I'm not really part of the HLS program. I've not heard what their plan is. I think right now, right, the beginning, just like Orion, the goal right now is to demonstrate that we have a lander that's able to successfully bring, to take crew member from Orion in space into the moon and come back. Now, knowing SpaceX, right? I'll make this comment. Knowing SpaceX, they will make everything reusable. So I'm not going to be I'm not surprised at all that eventually everything they have is reusable. So and they have demonstrated they can do it. Go ahead.
One more. So I want to I'm asking how do you operate? Like I was the vehicle manager for Space Shuttle Discovery.
Yep.
And we had a 3-man team, or 3-person team.
Yep.
In JSC, KSC, and then the Rockwell.
Mm-hmm.
So you have a KSC counterpart and a McDonald Douglas counterpart.
Yeah. Yeah. Matter of fact, I do. So it was kind of funny because for the longest time, there's not an Orion vehicle manager. The Orion Program Manager was acting as a vehicle manager because we were so focused on just launching that vehicle, Artemis 1, right? I mean, that's all all the effort and focus is on that vehicle, right? So what the program manager essentially is taking care of everything. But eventually, when we started building up Artemis 2, the crew module, and the number 3, there's no way he can do it all, or she can do it anymore. So they started asking for, so that they wanted a vehicle manager, and of course that's when I applied because that's the job I want, right, Stokes? So, so I have a counterpart with Lockheed. It's my counterpart is actually Lockheed mission manager for each of the vehicle. Okay, they don't call it vehicle manager. And then at KSC, there's that we have a resident. I'll call we get the Orion Production Office at KSC, and then they also have a person that they call it the flow lead that follows that vehicle, and then very similar to Lockheed and the Lockheed ground operations, they call it. They also have a similar flow lead as well. That's essentially the NASA flow lead's counterpart. Very similar to the shuttle days where we have USA. Right, flow manager, then you got NASA flow manager, and then at JAC we also have a vehicle manager. Very similar to that, very similar concept. So that's how we're operating today, and it's working quite well. Yes.
This kind of goes with your reuse parts type question, but now added manufacturing. Do you know if they have, if NASA has implemented any steps to evaluate post-mission, like when they back Orion 2, the parts that have been added manufactured through just like 3D printing and stuff? Because I know based on an intern presentation a few weeks ago, he was talking about it. I was wondering, do you know anything about how maybe they're going to evaluate the freshman returns to see how they behave since there's such a limited amount of research maybe?
Okay.
Or does it make sense?
Yes, the question was, is there any plan to remove some of the 3D manufactured hardware from Artemis 1 or even for future flights and to assess its performance and then so that we can essentially improve it, right? I actually don't know the answer. I'll be honest with you, right? So we, for Artemis 1, we took off the components as much as we can take off that's needed for Artemis 2. As I mentioned, the avionics boxes that were reused for Artemis 2. We quickly button it back up and we send it to Plumbrook or Armstrong test facility to do the environmental test. So we haven't done that yet. So I don't think there's a plan to do that, to remove those 3D printed hardware to do that. And also my understanding is that we don't have a lot of 3D printing parts. Matter of fact, and if we do, they are more secondary structure. They are not primary, load bearing structures, that you really want to take off and do all your stress analysis to determine what the fatigue factor and how much the life is left. So we don't have that right now. So maybe in the future, as we go to reusability, maybe that's something that we'll consider as the whole 3D printing technology gets better, more mature, and we are able to certify and get confidence of all the material property, consistent material property. I think that's something that we might consider in the future.
It wasn't in the engines.
No.
It was not.
No.
It wasn't in the engines. Like, I think they're doing some 3D printing in the SLS engines.
Yes.
We don't have that on the line.
Okay.
Yeah.
Because I know someone was mentioning that there's over 200 parts on Artemis 2. I may be incorrect by that amount that is being added and manufactured. But like saying, probably most likely secondary.
Yeah, the majority are secondary structure. Yeah.
But I was saying like the engines.
Yes, engines. So no.
Yeah.
Okay, so that's awesome. I'm just trying to make sure that. Thank you.
Okay. Oh, so the summary of that discussion was that we currently don't have a lot of primary, I call it primary structure, being the load bearing structure. They are using a 3D printing technologies. I think maybe in the future we'll do that as the technology matures and we're able to get consistent material properties that way. Again, primary structures to us, I mean, the reason why they are primary structure is because they are load bearing, they are critical. And we need to make sure, absolutely be sure, there's no redundancy, right? So if it fails, it's a bad day. So we need to make sure that absolutely that piece that we built, I don't care if it's forged, I don't care if it's, it's a machine or it's 3D printed, we had to know it's proper, we had to know it actually works. And I don't think we are there yet with 3D printing yet. And counting on that to be our primary structure, I don't think we are ready at this time.
Do you know what that margin is for structure?
It's still 1.4. It's always 1.4.
So it's 1.0 plus.
We always do for 1.4. Yeah. Well, 1.0 obviously.
Last call. Close the bar now.
All right.
All right.
Thank you all so much. It's really glad to see some of the old faces being like, I knew I said the wrong word. Some of the familiar faces that I used to work with. There you go.
Thank you so much. Yeah, appreciate that. All right. Really appreciate the presentation. Thank you so much, Frank. I know you're probably somewhere in the middle of the Pacific in terms of adjusting back to the right time zone. So appreciate you taking the time to join us today. Thanks to everybody in the room for sticking with us as we once again were bitten by all sorts of technical issues with the Zoom. Appreciate everybody who hung in there online. So I just want to remind everybody we were able to record this presentation, so the recording should be available on the NAL website in a couple of days. And then another reminder that we will not have a first Thursday program in July because that falls on the 4th of July. However, we are going to have a social event on July 19th from 2 until 6 p.m. in the Gilruth Ballroom in commemoration of 55th anniversary of the Apollo moon landing. So the event is going to have a panel discussion. Our panel speakers are going to be Fred Hayes, Gene Kranz, and Bill Moon. And our moderator is going to be Denny Holt. So that's going to be a lot of fun and really exciting. NAL members, you should have received an email about that event sometime within the last couple of days. Registration is open right now. Registration is only open for NAL members. We are capping the attendance at this particular event at 200 people. We want to make sure that everybody is going to be able to see and hear the panel speakers. So we're capping it at 200 people. So get your tickets early and often. If you want to attend, ticket sales will be available. If we still have capacity, ticket sales will be available to the general public, like to everybody, starting on June 28th. So if you plan to come, strongly suggest getting your tickets. So hope to see you all there. Thank you very much.
Beer?